Okay, now taking u equals tan inverse of x and v is equal to 1. So taking the derivative du upon dx, that is 1 upon 1 plus x square, integral of v of d of x, that is x, using the formula u into v d of x, that is u into integral of v minus integral of du upon dx integral of v dx into dx. So value of u is tan inverse of x minus, writing the derivative of u, that is 1 upon 1 plus x square, that is x here. We can write this in this form also. Now writing this 1 upon 1 plus x square in this form. So to get the derivative here, we can multiply this part with multiply and divide with 1 upon 2, multiply and divide by 2. So we will get 2 here, and by dividing we are going to write this 1 upon 2 outside here. So now we can write this as a, so we have the function here and its derivative also. So we can write this 1 upon 2 ln 1 plus x square plus c. So this is our final answer. Okay guys, this is one of the lengthy questions of the exercise. So before applying the formula of integration by parts, we are going to rearrange, just modify this question. So we know that cos of 2x is equal to 1 minus 2 sine square x, and from this we are going to find the value of sine square x, which is sine square x, that is 1 minus cos 2x upon 2. Just put the value here. This will give us 1 minus cos 2x upon 2, and taking this 1 upon 2 outside and multiplying this x power 4 inside, this will give us x power 4 minus x power 4 cos of 2x dx. Okay, so 1 upon 2, applying the integral on each part, x power 4 dx minus 1 upon 2 integral of x power 4 cos of 2x dx, right? So 1 upon 2 x power 5 upon 5 and 1 upon 2 integral of x power 4 cos of 2x dx. So we can write x power 4 upon 10, and applying this x power 4 cos of 2x dx. Okay, applying the integration by part for this section, by taking u is equal to x power 4 and v is equal to cos of 2x. If we take the derivative of u, that is 4x power 3, and integral of v dx, this will give us minus sine of 2x upon 2. Putting the values here in the given question, minus 1 upon 2. Now what is the original function? That is x power 4. Integral of the function, that is minus sine 2x upon 2. We are actually directly putting the values in the formula. Integral of the function, what is the function? du upon dx, that is 4x cube, and the derivative of the function is, take this sign minus here, sine 2x upon 2 d of x. I have just directly inserted the values in the formula, and this will give us 10 minus, and this is plus x power 4 sine 2x upon 4 minus plus, and that plus into minus is minus 4x cube sine 2x. Sorry, that's we are going to apply this integral here upon this 2 and 2 is, that gives us 4, and we have integral sign over here. So we can cancel out this 4 and a 4 here. X power 4 upon 10 plus x power 4 sine 2x upon 4 minus integral of x cube sine 2x dx. So you can see we have to apply the formula again on this part, and we are taking this as I1. So, and I'm going to name the equation, that is name this equation as this as A. Keep this in mind, this is A, our equation A, and we are going to simplify this by the I part again by applying the formula. Okay, so now taking u equals x cube and v equals sine of 2x, which is ultimately d upon dx is equal to 3x square, and integral of d of x, that is minus cos 2x upon 2. Putting the values in the formula, which is integral of I equals now u, what is u, that is x cube, and what's the integral of dv upon dx, that is minus cos of 2x upon 2 minus integral of du upon dx, that is 3x square. What is the integral, that is minus cos 2x upon 2 dx. Just put the value directly into the formula, and I have now minus x cube cos of 2x upon 2 minus, take this 3 and this 2 outside with negative sign, this will give you plus 3 upon 2 integral of x square cos of 2x dx, right? So again this is I1, and now this is take this this is I1, and now take this as I2, right? So name this equation as equation number B, and now taking this I2 here, I2 for to solve I2, which is x square cos of 2x dx, taking u is equal to x square and v is equal to cos of 2x, derivative of which is 2x, and integral of which is cos of 2x, that is cos of 2x, that gives us integral of this part is now integral of which is now sine 2x upon 2, right? And now putting the values into the formula, which u, that is x square, integral of which is sine 2x upon 2 minus integral of which is the derivative 2x into derivative of the sine 2x upon 2 dx, which is x square sine 2x upon 2, 2 and 2 cancels out, integral of x sine 2x dx, right? Name this equation as C. And lastly, taking this one is I3, that is integral of x sine 2x dx, taking u is equal to x and v is equal to sine 2x, derivative of which is 1, and integral of v, that is minus cos 2x upon 2. Putting the values into the given formula, what we have to do, that is by putting the values into the formula, what is u, that is x, and what is the integral, that is minus cos 2x upon 2 minus integral of what is du upon dx, that is 1, and what is the integral, that is minus cos 2x upon 2 dx. Okay, now taking the integral, this will give us I3 will be finally minus x cos 2x upon 2, and this will give us a plus sign, and the integral of this, take this 1 upon 2 outside here, and integral of cos of 2x dx, this will be, this is basically I3 minus x cos 2x upon 2 and plus 1 upon 2, this will give us sine 2x upon 2 plus c, and I3 will be ultimately minus x cos of 2x upon 2 plus sine 2x upon 4 plus c. So now by this equation, and this equation is D, right? Now what we are supposed to do, we have 4 equations, that is A, B, C and D. So first of all, what you have to do, you have to place substitute this D in place of C here, and the expression, the sentence you are getting here, just insert it into B, and the expression that you are getting here, put it in place of A, you will get your final answer. So let's do this now. So these are our equations. This is the first equation, right? This is I, this is I1, this is I2 and this is I3. Okay, so we are going to substitute this D in place of this I. Okay, this is the part, in place of this we are going to put this whole part. We got final value of I2, and now going to put this value of I2 in I1, where the value of I2 is this part. In place of this part we are going to substitute this whole sentence. This is the sentence we got in place of I, which is the final value of I1, and after getting this part we are going to substitute this whole sentence into I, which will give us the final answer. You can see I have substituted the value of I1 in place of this part, which I have already named this as I1, and the first 2 parts are written here, and now I'm going to remove this bracket, which will give me the final answer, x power 5 upon 10 plus x power 4 sine 2x upon 4 minus plus x power 3 cos of 2x upon 2 minus 3x square sine of 2x upon 4 plus minus 3x cos of 2x upon 4 minus plus 3 sine of 2x upon 8 plus c. So after now combining the parts of sine 2x and cos 2x, I'm going to combine this part and this part. Combining these 3 parts and combining this part and this part, taking the common part, we get this part, which is our final answer.